we're going to start looking at shortcuts to get similar triangles. Okay. Triangles are the most useful shapes because with triangles you can make any of the other polygons. As we saw from last chapter, we can always break a bigger polygon up into multiple triangles. So that's why we focus so much on triangles, and this is also going to lead us into the next chapter, which is on trigonometry. Trigonometry is all about right triangles and the relationships within them. So this idea of similarity is a big one, and we're going to be using it to figure out some trigonometry as well. So it's important that you get this. So if two angles in a triangle are congruent, then the triangles are similar. Okay, so a real quick proof of this. Okay, let's say I know that this is 50 degrees, this is 40 degrees, and I have some other triangle that also has a 50-degree angle and a 40-degree angle. Well, I know this is 180 degrees total in here. So if these are 90, that's leaving 90 for this last angle. Same thing here. This is also leaving 90. So having two congruent angles guarantees that the third one's going to have to be congruent. And of course, if these have all the same angles, then it's going to turn out to be the same shape because there's only one configuration you can put these three angles in so that they, make the three angles. They could be different sizes, but the general shape is going to be the same. So this is our first way to prove triangles are similar. So if we want to do a proof, okay, I'll do a 2-column this time. You can still do flow proofs if you want. So here I'm given that angle B is congruent, or angle B and angle L are right angles. So that's marked on my picture. Okay, therefore angle B is congruent to angle L because they're both right angles, which is really the right angle congruence theorem. And then I can say that this angle is congruent to this one. So AHB is congruent to angle LHK because those are vertical angles. And now I've got two congruent angles in this triangle and this triangle. So I can say that the triangles are similar. Similar to triangle KLH by the angle-angle similarity postulate. Okay, so AA. Now, if you notice, we only need two angles, so we don't even need to know anything about the sides. If we get two angles, we have similar triangles. What this means is that there's a constant ratio between the corresponding sides. So if this is 10 and this is 5, that's a 2-to-1 ratio. So 8, that would make this 4. If this is 14, this would have to be 7. That doesn't really work because these are right triangles and these won't meet the Pythagorean theorem, but that's just an example of what we would know. Okay? All right, so we can use similar triangles to set up proportions and solve for missing pieces. So I need to find the length of MS. MS is a median. Okay? And even though it's not a side of our triangle, or it's still going to be proportional to the corresponding median of the other triangle, as long as these are congruent or similar triangles. So first we have to figure out if these are similar triangles. Well, I've got these parallel lines here, and this would be a transversal. Okay, this red line is a transversal because it's touching both of my parallel lines. Okay, So I could extend these lines a little bit. Let's see what that would look like. Okay, and then this would be your transversal that's coming across both. And so if you can see here, this angle and this angle would be congruent. Or no, not that one. Sorry. Oh, let's see. Let's extend these a little bit further. I don't want to use that transversal actually. The more I look at it, I'm going to want to use this bottom line as my transversal. Okay, so this is my transversal that's coming across both lines. So let's get rid of this one. Okay, that would make these angles corresponding. So I've got right angle here. This was a right angle. I kind of erased it. And I've got right angle, congruent angle, right angle, congruent angle. So these are similar triangles because angle, angle. So therefore, I need to find out the ratio or the scale factor. The big triangle is 15 over 9. That's going to have to correspond to 12 over whatever ms is. I could reduce this. Okay, I could reduce this to 5/3 just to make my math a little easier. So cross multiply, I get 36 equals 5 times whatever ms is. Divide by 5, I get 36/5, which is 7.2. Okay, so that's how long ms would be. So you're still just using proportions, but it doesn't only apply to sides. It would apply to corresponding altitudes, medians, angle bisectors, perpendicular bisectors, things like that. They're all proportional to each other. Here's another way we can do it. You're standing 15 meters from one building that is 90 meters tall. So this building is 90 meters tall. And I'm standing 15 meters away from it. Well, it looks like I want to do this the other way. Because I'm 50 meters away from another building. So I'm closer to this building, so let's make that the 90-meter one. 15 meters away from here. This is 90 meters tall. I'm 50 meters from this building. Okay, the angle formed with the roof of each building in your position is the same. So the angle formed from me, this is where I'm standing, and the roof. Well, so the roof and me make this angle, and it's the same as this one. Okay, now I need another angle, but since this is sitting on the ground, and we don't want the Leaning Tower of Pisa, we want to have right angles there. So I've got angle-angle similarity, so I know that I'm going to have proportional lengths. Okay, so I could set up my proportion different ways. I could compare the ratio of the sides in the one triangle, so I could say 15 over 90 has to equal, okay, so this is ground to height, so I need ground to height. Or I could compare the two ground things together. I could say 15 over 50. So ground of the small, ground of the big has to equal height of the small over height of the big. Either way, when I cross multiply, I'm going to get 50 times 90 equals 15x. 50 times 90 equals 15x. Okay? So 50 times 90 is 4,500. If I divide that by 15, 15 goes into 45 3 times, and then it'll go 0, 0. So it's 300 meters tall. Okay, so this building here is 300 meters. All right, and those are examples of how you can use angle-angle similarity and, a bit of a word problem in there too.